Thanks. So I've got 3 slides to make 3 points and 3 areas of sort of broad comments about research that I think come out of it. The first comment is that I think there are perhaps more reasons to be optimistic than have sometimes come through. This is a very simple slide that I drew up last week, looking at the costs we now know that wind and solar energy can be produced at, compared to the numbers in IPCC Working Group 3 for onshore wind on the left and utility scale solar on the right. So I'm not saying that IPCC Working Group 3 got it wrong. I was an author in it, so I wouldn't say that. But it's 5 years, and the stunning message is that in those 5 years, wind has got cheaper by a factor of 2, and solar by a factor of nearly 3. So I don't think we have to wait for CCS, Stuart. I think we will, particularly in the tropics, solar at these prices outcompetes where CCS will ever be. It certainly outcompetes nuclear. And even more importantly, it potentially outcompetes carbon-intensive means of power generation. So I think the good news for the electricity sector is that the renewables revolution is coming. That doesn't mean it will be easy. There's a big piece of work to do in how we integrate renewables into grids. And because I know Achim Steiner's here, I should give a plug to the Oxford Martin programme on integrating renewable energy that I'm involved with. So there are people beginning to work on these issues. And I think it's overcoming those, not just the technical changes that are needed in grid systems, but the social, the industrial, and the policy inertia that goes along with. That will be the key question in how quickly we can begin to get the peak and how steeply we can begin to go down the sort of curve that Elmar showed earlier. So there's some reasons to be optimistic, but there's some reasons to be cautious too. And I steal the CCS plot from Stuart to show here rather than to do with electricity, because I think this is where CCS may be needed. We've seen similar lists before: aviation, shipping, agriculture, industrial processes, space heating. There are ways of decarbonising these. Technically, we know how to do these things, but it's more difficult. To what extent will it be CCS? Will it be power to gas technologies? What will the vectors be? Will it be hydrogen? Will it be other fuel or other synthetic fuels? To be honest, I don't think we know. So the challenge to the research community is begin to develop cost-acceptable approaches to those difficult decarbonisation technologies. I'm not going to say a great deal about negative emissions technologies because a lot's been said. I broadly agree with what Janos said this morning, actually, that they're unproven in scale. We don't know much about the cost, and we don't know much about the social acceptability. I don't think those problems are going to be solved on the timescales of the IPCC special report, but that doesn't mean we shouldn't start down the track. And as Pete Smith said yesterday, we're only going to find out about some of those issues by demonstrating the technologies. And my third point, and those of you who will know me will not be surprised to see me make this point: sustainable consumption really matters as well as sustainable production. In the parallel session we had yesterday, that came out about urban systems. It came out as a key issue in food systems. It came out as a key issue in transport systems. Almost all the assessments we see, whether it's from the IEA or anybody else, says that something like 50% of mitigation will come from the demand side, not the supply side. And yet, that tends to get marginalised in climate debates. I think one of the reasons that happens is that some of our models don't treat it very well. They assume, for example, that there are no negative cost emissions, which is simply untrue. They assume implicitly that high consumption lifestyles are preferable, and all the debate we had yesterday would indicate that, well, that is not necessarily the case, at least in high-income countries. We know that the sustainable consumption technologies in buildings and transport is where most of the investment is needed. AR5 tells us that. There's also huge skills shortages. It's one thing to know that we can, in principle, build a zero-energy building. It's another thing to make sure that every building that gets built is a zero energy building. And those are the sort of challenges where I think skills investment are really urgently needed before we start to worry about deploying negative emissions technologies.
Okay, thanks very much. That was a very good summary. I hope slide sets like that are actually coming out of all of the breakout sessions. That'd be a useful thing, I think, to have on the website maybe at the end. Sorry, I shouldn't. Okay, we've got time for some questions. I thought there'd be lots of hands. Let's have Mike down here first. We'll go in batches of 3, as before.
Shout anyway. Oh, that's better. I want to talk about natural mitigation pathways, and particularly, it seems to me it's a no-brainer to do for so many reasons, but the only way it's going to happen is by integrating into a series of other policy agendas around biodiversity, around development, around quality of life as well, and also climate change adaptation, ecosystem-based adaptation. So I'd like to know your thoughts, particularly Bronson, on how we integrate climate change mitigation into those other agendas and vice versa. I know there's one specific hook that I think is perhaps worth considering as well, is the commitment under the Convention on Biological Diversity, under the Aichi targets, to restoration of 15% of degraded ecosystems for climate change adaptation and mitigation, and whether that provides us with a really specific opportunity to encourage, cajole governments into actually delivering on that commitment that they have signed up to.
Okay, let's take one from this side. We'll take one at the front first, then one further back.
Hi, I have a question on CCS. Can you please comment on the costs in terms of energy that CCS bears? So basically, do we need to burn more carbon to store carbon, and what are the dimensions of that?
And then at the back, just next to the aisle, about 2/3 of the way up.
Thank you. My question's for Stuart. Why does the focus on CCS seem to be so heavily focused on coal rather than gas, given that gas is killing coal in many markets? Also, gas could potentially play important roles in transitioning to a high renewables grid. And then thirdly, my understanding is gas CCS can work at smaller scales. You have natural pipeline pathways, things like that could make it more attractive.
Okay, do you want to start it?
Well, thank you. That's a great question. I honestly don't, I don't have a simple answer, of course, to how do we sort of cajole and given I would absolutely agree. I think that in many ways it's a no-brainer, and that was kind of the spoof on technology was like, gosh, if somebody invented a tree, like, I think the investment community would go crazy. So I actually, I'll give you a very sort of silly answer to it, which is that, or a non-technical answer, because we're getting into sort of questions that are sort of beyond my geeky expertise, which is I think nature has a major branding problem. And I think it's as simple as that. I really do. I think that nature, we just as a modern human, global society, we think of nature as kind of this victim, and as kind of this frumpy kind of thing that we don't want to hurt, and we're worried about it. And we don't see it as a machine that can produce like all these services. I mean, obviously there's been a lot of work on this, right, ecosystem service, but we're still working our heads around it. And so I think that, the investment community, so it's not just governments, I think both governments and the investment community, needs to sort of wake up and realize that it's a no-brainer. So I think there's a big communications challenge, and part of that communications challenge is starting with, doing some of the just pushing the science to sort of clarify that it is a no-brainer. So yeah, I would agree with that. Final point, just very quickly on some of the policies that are already out there. We did sort of review some of them and compare it to our own findings, and what we found is that they're actually pretty consistent. A lot of the policies, if you just were to implement, like the you know, the forest, the Declaration on Forests, the bond challenge, and then what was the development SDGs? Is that?
No, it's the CBD.
Yeah, conventional biology, we looked at that as well. So a lot of them are actually quite consistent with if you sort of pack them all together, but they're actually quite vague. A lot of the terminology is very vague. And so the way you interpret those, implementing those, could generate wildly different kind of outcomes in terms of natural carbon storage. So I guess what we found is that clarifying the goals in more specific climate terms would be very helpful for making those more useful.
Stuart, do you want to take the second one and then Nick take the third one?
I might take the third one as well. I'll have a go.
Okay, we are
CCS Energy Penalty. So it's well understood that to separate carbon dioxide out from the flue gas of a coal plant or a gas plant or a refinery bits and pieces, you need to do some work on that, and that's chemical process work. So at the moment, the energy penalty is usually considered to be around 20% of the energy. So yes, you need to burn more energy. That's clearly able to go down with existing modifications of existing stuff, existing types of separation down to about 15-17% of energy penalty, so there's a gain to be had. But I also know that I'm sure that absolutely certain that the technologies which are invented already are going through into the technology proving and pilot stage, which will bring that separation cost down to just 5% maybe. And there's one particular turbine which was conceptualized in Britain as being developed in the United States because there's more money, which claims to be able to separate the CO2 out from flue gas on a gas turbine for no cost and be 2% more efficient than an existing turbine. So I'm optimistic, but unproven, optimistic that there will be step changes from the Model T Ford towards the Tesla within years rather than decades. Somebody asked me about focus on coal, not gas in the transition. Well, the focus on coal is because, as we know, coal emits roughly twice the amount of CO2 per unit of energy, if you like. There's plenty of gas around, so we have to do gas as well. Gas is a low carbon fuel, but not a zero carbon fuel entirely. If people want to carry on digging up coal and burning it and converting it, then you have to do carbon capture on it. That's as simple as that. Personally, I think coal production is a lot more difficult, a lot more dangerous, has much more environmental impact at the sites of production, and it's a lot more difficult to reduce emissions along that whole supply chain compared with gas production, transport and use. And yes, you can separate CCS on gas at much smaller size scales. We can have a benchtop gas separator here which works compared with if I wanted to do separation on much more dirty coal flue gas, then I'd need a much bigger piece of unit. So that tries to answer all of those.
Okay, well I think you answered Nick's question.
Can I just add a bit?
Very briefly. Very briefly.
The use of CCS on gas-fired stations in the context of high renewables grids is a bit more problematic, partly because they are, as I understand it, that they are less flexible than gas plants without CCS, and partly simply because the running hours are lower and therefore the economics of putting CCS on are worse. So I think it's an open question if and when batteries will play that role as opposed to low operating hours gas-fired power stations.
Okay, no, we're going to leave it there. After we're running too short of time, we can take it out. Yeah. Let's give a round of applause to the speakers, please.